Okay. So, on the 7-6, I'm going to show you first how to do it with the graphing calculator. And what's kind of cool is this will actually show up on my screen now. So if you look at it later, it'll be there so you can see where all the button presses are. But if you don't have access to a graphing calculator, and again, you can get it right online. But if you don't, I'll show you how to do it algebraically too, to be able to get to the answers. So here's how this is going to work. When I go to do these, let me get my calculator turned on here, my virtual one. Okay. What you're going to want to do is you're going to take each side of your equation and you're going to get to the y equals and you're going to type each part separately. So you'll notice on here, my square root of 12 minus n, I put up here in the first y equals. And then the other side, it just says n, and again, I don't want to use n, I'll use x. So basically, I have y equals x, and y equals the square root of 12 minus x. Because if you're trying to solve one of these, if you graph each one, the place that they intersect is actually your solution. So just so some of you later will have this to be able to see, I'm just going to literally write the instructions for the calculator on here so you can see. So we're going to plug each side into the graphing calculator. And you'll see that on the screen if you look at it, like, whoa, my screen disappeared. It's in battery save mode. Okay. Each side needs to be done separately. So I do the square root of 12 minus x, I do this, just the x. When I go to graph this then, you should get something that comes up on your screen like this. Now, if your window's off, maybe you'll see something different, because the typical window will be from -10 to 10 for x and y values. And you'll notice they cross in one place. That's what we're trying to figure out. What's the x value at that place where they cross each other? So to do that, here's how this is going to work. First thing you need to do is you need to hit the second button, and you need to hit the trace button, because that's going to bring a menu up for you that looks like this. Yep, and we're going to look for the place that's an intersect. So second, trace, and 5, which is the intersect button. We want to see where they intersect. So whether you hit 5 or scroll down there, and then you're going to get this little thing that talks about the curve. Now let me explain this a little, because I want to keep this simple for you. That little blinker, okay, our little cursor can be anywhere on that curve. All you have to do is hit enter once, then you see the little cursor moves to the other line, hit it a second time, and guess, we don't even need to play around with this. So basically, once you get it set, we're going to hit enter 3 times. Once the screen comes back up with the blinker, if you hit enter 3 times, it'll tell you where the intersection point is at. And whatever the x value is of that intersection point is the answer. So in this case, my value would be 3. Because I don't need the y, all I want is the x. And to be sure, this is the other nice thing, if I were to plug it in, let's see what this would look like if I just wanted to check. Is the square root of 12 minus 3 equal to 3? 12 minus 3 is 9, and the square root of 9 is 3. Check. Okay, that works. So that's all you have to do if you want to be able to try to kind of keep life simple on something like this. Now, I want to take a look at a couple others using the graphing calculator, and then I want to work through one with you, doing it algebraically, just so you have some options here available. So I'm going to skip 2 for right now. I want that to be my algebra 1. So we're going to come down to number 3. So I'm just going to boost this up a bit. We're going to keep using those same instructions that we did up above. So let's get turned back on here. So we'll go. What's that? We're going to do number 3. So we're going to get everything cleared out from the first one. So here I've got the square root, and again, square root is second and the x squared button. And then just type in what you see. So 65 minus 7 and the k, we're just going to use it, oops, not 8. No. That's that. So 65 minus 7x. Okay, and we're going to keep each half separate. So once you get that first one done, why does this keep doing things to me that I don't want it to do? Another wonderful Harty video moment. Yeah, but some of you can make a blooper thing for me at the end of the year here. Okay, let's try this again. And then the other side's just the k, or in this case the x minus 11. So once you get those in there, I'm going to graph. Let's see what happens here. Well, now let's not say it doesn't connect. Let's double check here. You check the window, it doesn't cross. So you're like, this is kind of interesting. So let's see, if we don't change the window, let's test this out for a second. So if I go to my second trace again, and hit 5, and I try to do the intersect thing that I did before, let's see what happens. So my first curve, you see my blinkers on my top one, my square root function. So I'll hit enter. Then you're like, I don't even see the other curve, Harty. Where'd it go? What I can do, let me get back into the screen. There it comes, okay? I can keep using the cursor buttons on the sides to be able to get to that part. And if I keep hitting enter, let's see if it, error. Which basically means that they aren't going to end up crossing each other. So does that mean I have no answers? They're like, no, yes, no, yes. Okay, here's how we're going to double check. Since going to the graphing calculator didn't necessarily work here, if we were going to do this algebraically, what would I have to do to get rid of this radical? I'd have to square it. So we're just going to do a little double check here, and it's going to let us see how the algebra part would work anyway. So since we've got that, let's see. So the squared and the square root would cancel. We're just going to double check for this one time. Now here's where we got to be careful. K minus 11 squared is not just k squared plus 121. Remember, this is actually k minus 11 and k minus 11. I have to FOIL this out. Now, some of you have found that using that box helps you to organize so you don't forget terms. Okay? So if you were to go that route, some of you are fine with your FOILing. You can just keep doing it as you have been. And as I fill in the box, I multiply. So I start to work my way through here. And I find out it's good that I didn't just square the first and the last terms. I still get the k squared. I still get the plus 121. But negative 11 and negative 11 is negative 22k. So that's what this side of my equation ends up being. And you're like, oh, I see what's coming. K squared's where the party's at, just like it always is. So everybody wants to be on the k squared side. So I'm going to have to subtract the 65 over, and I'm going to add the 7k. We're just going to do this here, like I said, kind of as a test to see if the calculator's gone crazy or if we actually have something to work with here. So those cancel. So let's see, negative 22 plus 7 is negative 15k. 121 minus 65 is 56. Can we factor and get two numbers that multiply to positive 56 and add to negative 15? Well, yes. What's that? What are they? 7 and 8, and they're both negative. So you're like, well, wait a minute. So if I set those each equal to 0, I do get two answers. So why aren't they showing up on the calculator? What's up with this? Okay, let's think about this for a second. You're like, no, we don't want to think. If I plug these in, let's see if they work. So if I plug in the 7, 65 minus 49 is 16. Is the square root of 16 equal 7 minus 11? Does 4 equal negative 4? No. Okay, so that 7 doesn't work. Let's try the 8 out. So 7 times 8 is 56. 65 minus 56 is the square root of 9 equals 8 minus 11. Square root of 9 is 3. Does 3 equal negative 3? No. No. So, what we saw in the calculator, which basically was there isn't a solution, there's not an intersection point, is true. There isn't a solution. And that's why dealing with the calculator can be such a wonderful thing, because notice, us just plugging in those two expressions and seeing that they don't have an intersection point works a little bit faster than this does. Okay, it's possible, but it's one of those things that if I do it algebraically, I got to make sure I check my answers. Because sometimes I may get one that works and one doesn't, or in this case, neither of them work. I did all the correct work, all my algebra is perfect, but if I had just circled it and said, ooh, the answer is 7 and 8, I'd be wrong. So that's something we have to be cautious of. Now, one other interesting thing to be cautious of. I guess I'll just keep working my way down here, and then we'll work over. Here's the one other thing that you have to watch for. Your radical must be isolated before you plug it in the calculator. What do I mean? Well, like in this one, for instance, I've got k equals 3 plus the square root of k minus 1. This k minus 1 has to be on a side by itself, or this doesn't work. Well, it doesn't work as well. Let me just put it that way. You still can work your way around it, but there's a reason for that. So how can I get the 3 out of there? Okay. Because this is also going to help us out if we decide we want to go back and check algebraically in a minute. So let's try this guy out here. Let's see if Harty's learned better how to play with this. I need a mouse. All right, let's get cleared out here. All right, so we got x minus 3 for one of them. What's that? The square root one first? You sure could. Yep. Yeah, the order of these doesn't matter, as long as you get them both in. So then here, we've got the square root of, in our case, x minus 1. And again, if you had the square root on top and the x minus 3 on the bottom, that's still okay. Hey, at least we got a cross this time. So I look at that and I say, okay, so I see there is an intersection. So we're going to do second and trace, because that'll get me to my calculate screen. We want the intersect, so it's going to be 5 like it was before. And again, There's my blinky guy, so I'll hit enter there. My second curve, you're like, where'd my blinky guy go? You're still safe to just hit enter, enter. Because, or maybe not. It doesn't like my second curve. That second curve. There he is. Okay, there's my blinky guy. I just used my arrow right to get him to come back up. Because here's what had happened. You're like, well, why wasn't the blinky guy there to begin with? When I was on my first curve, it had my value here that it was looking at. So when it tried to go up to the second curve, there's nothing here. Because my square root function didn't start till I got over here a little bit further. So if you need to, you may have to arrow right or left until that cursor comes up. So there's my cursor. Now I'm safe just hitting enter 2 more times. So which one of those numbers is my actual answer? The 5 or the 2? Are they both answers? No. 5. Okay? Because on all of these, okay, the x value in your intersection is the answer. Or at least in this case, it's the possible answer. We're going to double check just to be sure, and that's one of the reasons I said getting that radical isolated helps. Because now I can just look and say, okay, 5 minus 3 is 2. 5 minus 1 is 4. Square root of 4 is 2. Okay, that's good. It works. So we're just kind of playing around with this sum. Seeing how it works. So let's just say we happen to scooch over to number 6. We'll try one more here and see how you think this is going. Oh, my calculator went. So, do I have to adjust anything before I start on this one? No. So I'm just going to clear these out. And then again, it doesn't matter which one I do first. So here if I do x minus 5 and square root of, come here, 5x minus 25. And let's see what happens. Now this looks interesting. It's looking as though there's a possibility that it may cross in 2 places. Because it looks really close here at the start, and it also looks like it might cross here. The calculator won't tell me how many solutions there are right away, so we may have to play with this a little bit. So let's try this out. So if we do second trace, do our 5. Now again, notice my cursor disappeared. But also notice that you see with the curve, the second one, it doesn't look like it starts out here until about 5. So I may have to keep going right with my cursor until I get into that area here. So I'm still going. I don't see it, I don't see it, I don't see it. There it is. Once I see that blinker, 2 enters is good. So I see that it says my intersection's at 10, 5. So again, which one of those would be my answer? 10, okay? Because it's always the x value. So let's see. 10 minus 5, we'll check here for a second. 10 minus 5 is 5. 5 times 10 is 50. Minus 25 is the square root of 25. That one works. Yep. Well, I was going to say, and this one, but I don't want you to look at it as the y will be the answer that works. That actually doesn't hurt anything. That's just going to change this. We can get that changed back. Okay, So on this one, yeah, I was going to say, there's a second answer to this one. And here's the part that gets a little bit more interesting. Because you're like, okay, this told me that that was the answer. So some people are saying that 5 is another answer. You know, what's up with that? So those of you that are telling me 5, did your calculator tell you x equals 5, or are you just kind of eyeballing it and seeing it? Okay, so let's go back and do second trace. Let's do the intersect again. So now, here's what we're kind of considering at this point. Okay, so you'll notice I'm back on the straight line. I'm back on the linear part. So if that's my first curve, my second curve, I'll start to look here. It's going to let me... now mine's not being as patient as I want it to be. It's not going to give me that something. Okay? So here's one thing I'll suggest. If for some reason when you're plugging these in, you get one, but you have this funny feeling that there's a second intersection point, and the calculator is not being kind to you. If you look at this, can't you actually kind of eyeball it and say, you know what? It looks like right at 5 here, it's going to do that. If you see something like that, here's what I'd suggest doing. Just out of curiosity, what happens if I plug in 5? Let's see if my inclination's true. So I'd have 5 minus 5 equals the square root of 5 times 5 minus 25. Well, 5 minus 5 is 0. 5 times 5 is 25 minus 25, which is also 0. That's true. So I have 2 answers. So don't let your eyes, think that they're playing tricks on you. If you think you see a second point, try it out. Okay, because sometimes the calculator, depending on how close it is to the beginning of that function, may not give you that second one. But this is kind of one of those rare case type things. All right. Anything I can help with on straightening out things? And again, you still can do it algebraically. If you don't like playing around with all the button presses and figuring out intersections and all that, you absolutely can do it like we did number 3 and just factor it out and then just check your answer. Because you don't have a ton of problems to do anyway. So anything issue-wise, again, talk to me. Because what you're going to be up to is the same stuff on the other sheets, just on the front, so I'm not going crazy with it. But again, find your values, find your solutions, algebraically or using the calculator. And then we can talk about that at the very start tomorrow before we get working on the